Gravitational field. Gravity was discovered by a United Kingdom person named Isaac Newton, who was a physicist. He was believed to be born on December 25th, 1643, as of the OS date, which is the old style date. People thought that they were celebrating his birthday on December 25th, but on the day when England took Gregorian calendar, it was seen that the England date before was behind with 10 days, and now with the Gregorian calendar, it was not believed that Sir Isaac Newton was born on January 4, 1643, because it was 10 days backward. He discovered gravity, and he was believed to form the mathematical expression used to calculate gravity, and this law also helped Kepler to form the movement of the planets around the orbits. And he also discovered the force of attraction that makes the moon, the earth, and other planets to stay in their position. So today we are going to be talking about the gravitational field. He also quotes a law of gravitational field that every particle attracts every other particles with the force proportional to their product of masses and inversely proportional to the square of distance. In the mathematical formula, it can be said as F equal to m1 m2 over arrow square. The m1 represents the mass, the m2 represents the second mass. The first one represents the initial mass, and the second one represents the second mass. And the arrow represents the distance between the two bodies. But when it's used for the magnitude, for example, in this question, the magnitude of the gravitational force, we use G, M1, M2, and arrow square. So now we'll be solving for the first question, which is two 5.0 kg spherical balls are placed so that their center are 50 centimeters apart. What is the magnitude of the gravitational force between the two balls? And normally G equal to 6.67 times 10 to the power minus 11. And before I go further, the distance is always calculated with meter. So let's solve the first question. As it says, so the number one question says two balls of 5.0 kg. So that means the balls will be at this, and they will have this center at 50 centimeters, and it will be 50 centimeters, and the other ball will come here. Right? So both of them are 5.0 kg, and the other one 5.0 kg. So we are going to implement a formula, which is F equal to Gm1 m2 over r squared. So as I said before, 50 centimeters. So before we can use that centimeter, before we can use this distance, we first change it to meter. So to turn it to meter will be 50 divided by 100. So this will give us 0.5. So now this is the distance we'll be using for calculating this number one question. So move on. Will be F equal to, as I said, the normal number for the G is, the gravitational field is 6.67 times 10 raised by minus 11. So, and then we'll go to the first mass. Since the first mass is 5.0, we're going to do that 5.0 times 5.0 over this meter, which is arrow square. So we are going to use it as 0.5 bracket square. So now we'll go and F equal to 6.67 times 10 raised by minus 11 times, we cannot turn this to 5.0 square, which is also known as 25, and we divide by the square of 0.5. So 0.5. So we are going to divide 6.67 times 10 raised by minus 11 times 25 divided by the square of 0.5. It's going to give us our answer as 6.67 times 10 raised to the power minus 9 Newton, which is the unit of force, since it's a gravitational force. So we are going to move on to the number 2 question.